Hi students, welcome back to my channel. In the previous videos I have taught you how to do the indefinite integrations and definite techniques. In this video I came to teach you one more definite integrations. Before going to the section, first we need to know that why we need to learn the definite integrations. There are many applications in definite integrations. In that, one important application we are going to learn it to find the area under the curve. And also remember that definite integrations has a unique value. A definite integration is integration of a to b f of x dx. What is a? A stands for lower limit and b stands for upper limit. To solve integration of a to b f of x dx is also simple one. See, one technique, limit as a sum. That technique I am going to teach you in this video. And this is anti-derivative or primitive. So after finding the antiderivative or primitive, we have to apply the limits a to b. That upper limit first and lower limit next. Before going to the limit of the sum, first we need to know three more formulas. Sigma n. What do you mean by sigma n? Sigma n stands for sum of n natural numbers. 1 plus 2 plus 3 plus 4 and so on n. And sigma n square. This is sum of the terms 1 square, 2 square, 3 square and so on n square. And sigma n cube. This is also sum of the terms 1 cube, 2 cube, 3 cube. This all first n natural numbers. So first one, sigma n is equal to n into n plus 1 by 2 and sigma n square n into n plus 1 into 2n plus 1 by 6. Sigma n cube, which is n square into n plus 1 whole square by 4. Now coming to the topic. Now let us assume that y is equal to f of x is a curve. This curve area with respect to x-axis, I am using the x-axis. With respect to x-axis under the limits a to b or between the limits a to b, I want to find the area of this shaded region. Actually, in the earlier small age classes, we have learned how to find the area of the rectangle, how to find the area of the square, how to find the area of the circle. See, those all the definitions are predefined and formulas also predefined, so we can use formulas directly. But here, if you see, this area is not a definite geometrical shape. So what we do? See, this area we are going to do split into infinite strips. That actually it is denoted. We are writing our n strips only. Remember that a and b, they are rational numbers. Between the rational numbers, we can write infinite numbers. So as in terms we are writing n strips only, but that is infinite values will be there. So infinite sum of all this. Infinite sum of what are actually this one? See, we are going to make finite strips. Each one looking like a rectangle. The fine strip, which is dx or h, a small value. The difference, small value. H value approximately 0. So after finding this all the areas, if you find the sum of the areas, we can find area under the curve. In our book, it is given clearly that given interval AB divided into n equal subintervals denoted by like x0, x1, x1, x2, xr minus xr and so on. See, what is x0? X0 is a starting value a. Next value a plus h, a plus 2h. See, they are all like arithmetic progression value. At last one, xn is equal to b, which is a plus nh. From here, we can make n as a subject or h as a subject. See, if you make n as a subject, b minus a by h, and h as a subject, b minus a by n. We have to note that one as n tends to infinity. See, I said you already infinite values. That is only he is trying to say n tends to infinite value. Look, h is equal to b minus a by n. I have done it. As n tends to infinite, then 1 by n value becomes 0. When 1 by n becomes 0, h value also becomes 0. Already I clearly said it. N is infinite values. N is infinite values and h is tends to 0. Now one more formula you have to understand. What is integration a to b f of x dx? Limit h tends to 0, h into f of a plus f of a plus h and so on f of a plus n minus 1 into h. What is h? H stands for b minus a by n. H stands for b minus a by n. Wait. We have done already here. H stands for b minus a by n. B stands for upper limit, a stands for lower limit, n stands for, we don't know, this is unknown value, n value. Now h value b minus a by n need to be substituted everywhere in this given formula. Now I'm going to explain you one problem based on this one. Here is a question. Find integration 0 to 2 x square plus 1 dx as the limit of sum. See, already I have taught you in that we can use one technique, limit of sum. Now we are going to learn another technique. If you know the antiderivative or primitive and apply the limits. Applying the limits. Now y is equal to x square plus 1. Y is equal to x square plus 1. If you know that is primitive. For x square, x cube by 3. For 1 it is x. Apply the limits. I told you already upper limit first. 2 cube by 3 plus 2. Apply the 2 and 0. The total answer will be 14 by 3. See, such a simple one. Now, one more technique which we are going to learn, that is limit as a sum. Now, actually y is equal to x square plus 1. It is looking like a parabola, y. Here the degree of the polynomial, that is x square, it is 2. It is 2. See, it is represented a quadratic equation. So, it is a parabola. If it is y is equal to x square, passing through the origin, But here, plus 1. It means y value increased from 0 to 1. So, this is a dotted curve is a new one. Now, between the limit 0 to 2, we want to find the area under the curve, 0 to 2. See, this is that we have to find the area. How to find the area? Already we learned the definition. By definition, integration a to b f of x dx, that is limit h tends to 0, h into f of a plus f of a plus h and so on, f of a plus n minus 1 into h. What is h stands for? H stands for b minus a by n. What is b here? B value 2 and a value 0. When you apply, h is equal to 2 minus 0 by n, which is 2 by n. H is equal to 2 by n. The given curve f of x equal to x square plus 1. Now apply all this into formula. 0 to 2, x square plus 1 dx. X square plus dx. Now limit h tends to 0. See, there is another formula we learned, right? That is h tends to 0 or limit n tends to infinity. So what I am doing, h I am writing directly in terms of n. When I write in terms of n, this is the formula already we learned. B minus a into limit n tends to infinity 1 by n and so on, f of a plus h and so on, f of a plus n minus 1 into h. That is the formula I am applying now. Now if you apply limit n tends to infinity, h value 2 by n, the definition f of a stands for 0. So f of 0 and f of 0 plus 2, f of 0 plus 2 by n and so on, f of 0 plus 4 by n and so on, f of 0 plus 2 into n minus 1 by n. This I taught you already. It is in the form of a plus h, a plus 2h and so on, a plus n minus 1 into h. Arithmetic progression. Now substitute all the values in the function. 2 by n, f of 0, 0 square plus 1, f of 2 by n, f of 0 plus 2 by n is f of 2 by n. 2 by n, write it, 2 square by n square plus 1 plus 4 square by n square plus 1 and so on. 2n minus 2 by n square plus 1. Now what I am going to do? I am going to simplify it now. What I am writing now, all ones from each bracket I am writing together. That is 1 plus 1 plus 1 plus 1 and so on 1. How many terms? N terms. And from the balance I am taking out 1 by n square. So that it becomes first there is no 1 by n square and there is no term. So let it be 0. If you add 0, no use. So now excluding the 0, 2 square, 4 square, 6 square, and so on to n minus 2 whole square. Limit n tends to infinity 2 by n, and this is n. Now 1 by n square. From all this, 2 square I am taking out common. When I take out the common, it is 1 square, 2 square, plus 3 square, and so on, n minus 1 whole square. That is looking like sigma n minus 1 whole square. Sigma n minus 1 whole square. Look at this. We learned already sigma n square, which is n into n plus 1 into 2n plus 1 by 6. But we needed sigma n minus 1 whole square. If you write n as n minus 1, and n minus 1 plus 1, which is n, and in here also n minus 1, if you write it, 2n minus 1 by 6. Now that I am going to apply here 1n square, here 1n gets cancelled. Now this 2 is a constant, will be bring it out, 1 by n carry inside, 1 by n into n is 1, and 2 square by another n square, n minus 1 into 2n minus 1 by 6. Now here n square, so each n sent inside n minus 1 by n, 2n minus 1 by n. Now 2 into limit n tends to infinity 1 plus 2 by 3 into 1 minus 1 by n into 2 minus 1 by n. Now n tends to infinity, right? So we can write it as 1 by n tends to 0. So 1 plus 2 by 3 into 1 minus 1 by n, 2 minus 1 by n. As 1 by n tends to 0. So write 1 by n value 0. 1 minus 0, 2 minus 0. 1 into 2, 2. 2 into 2, 4 by 3. So now 1 plus 4 by 3 nothing but 7 by 3. 2 into 7 by 3, 14 by 3 square units. Actually we got already 14 by 3 square units using the first technique. So the final answer is 14 by 3 square units. This completes the solution. Children, if you like my videos, please subscribe my channel for more.